On this example, let's observe if both the properties are holding or not. The two properties are, one is lossless decomposition and the other is functional dependency preserving. So let's see if lossless decomposition is holding or not. So what do I mean by lossless decomposition is, whenever you decompose it, we should not get any spurious tuples. How is it possible? If the common attribute is going to be a key on one of them, right? So what is the common attribute here? Common attribute is clearly B, isn't it? So B has to be a key on one of them. So let's see this. Is B a key on this? Clearly B determines C is there, therefore B can determine C, therefore B can be a key for this, right? So at least for one of them it is the key, so it is lossless, right? So definitely this decomposition is lossless decomposition, right? And what about FD, functional dependency preserving? We have these three functional dependencies. Now let us see what can be applied on each one of them, and then later we shall check out whether using them we can again get all of them back. What are all the possible functional dependencies which are non-trivial here? One possible functional dependency is A determines B, which is non-trivial, isn't it? And other possible dependency is B determines A. I am talking about what are all the functional dependencies which are having one attribute on the left, and then what are all the functional dependencies which are having two attributes on the left. Since there are only two attributes, if I take two attributes on the left, whatever I write here, it is going to be trivial, isn't it? AB or A or AB determines AB or AB determines phi, all these are trivial. So these you need not check them. I am interested in only non-trivial dependencies. They are important. Trivial dependencies are never important, right? So only non-trivial dependencies that could be possible on this table are only these two, right? And now I want to see whether these two are can be derived from the given dependencies. Now watch it. From the given dependency, can this be derived? How can I find out? From the given dependency, you have to find out A plus, right? If you find out A plus from the given dependencies, it is definitely containing A, B and C, right? Therefore, A plus contains B. So A determines B is definitely possible on this, right? And what about this one, B determines A? Again, you have to find out B plus, right? If I find out B plus there, it contains B, and because of B, C, and because of C, A. Therefore, B determines A is definitely possible. So these two functional dependencies are possible on this table. Got it? Now the original set is divided into two sets. Now one set is containing these two functional dependencies. Now I want to see what the other set contains. Again, I want to see if these two are the non-trivial dependencies, right? B determines C and C determines B. Now I want to check if these two are possible or not, right? So how can we check it? B plus. If I find out B plus is going to give us, one is B and then C and then A. Here we got it, right? Yes, B plus is already containing C, it is possible. And what about C plus? C plus is containing C, and because of C, A, because of A, B. So it is C plus is containing B. Yes, these two are also possible. Therefore, this set is also possible on this, right? So from the given functional dependencies, these two sets are applicable on these two tables. Now, what is functional dependency preserving is, if I take the union of these two, right, these should cover them, which means all the original dependencies should be derived from them. Now check this. From all these four dependencies, can I get A determines B? Yes, A determines B is there. And can I get B determines C? Yes, B determines C is there. Can I get C determines A? Directly not, but then on this set, on only this set, if we apply C plus, then what do you get? Only on this. Because of this I get CB, right? And because of this I get A. Therefore, C determines A is still possible from this. So it is also covered. So we are able to cover all the original functional dependencies without any loss. So what can I say? All the functional dependencies are also preserved, right? So from this, this kind of decomposition is lossless as well as FD preserving, functional dependency preserving. Okay.